Now we're back. Make this bigger so we can see it better. Okay. So that's at about 7 volts. Now what I want to do is add my gating in there. So I need to do okay, I need to do that. There we go. Here. There we go. There we go. There we go. I'm all wrong. Okay, so now we can lower these to the point where I'm still getting maximum voltage. Oh, okay, now we're making progress. I'm just playing with duty cycle there. So actually, might be able to tune this different than I think. What? No way. Check that out. Okay, I changed my duty cycle, right? I need to make this longer. Okay, I changed my duty cycle. My amperage is no longer showing any amperage at all. Like none. Look at this, I can keep climbing. Wow, check that out. No way. I'm at 300 volts peak to peak. I'm gonna take my probe off. I'm gonna keep cranking it up and see what happens. I'm gonna clamp my probe. See if I can get anything out of it if I just clamp it on here. Can I see anything there? Yeah, I can still see what's going on. So let's see if it keeps climbing. Okay, we're maxed out. We're at 30 volts. Oh, I smell ozone. There's something. Hey, those are good signs. Really good signs. Let me put this resistor on my... That's some serious stuff. I'm not pulling like any amperage at all on my thing. So I changed the... Let me turn this voltage back down. This is ridiculous. I may not be making gas, but something interesting's happening. Okay. Very interesting. Is anybody watching this? This is pretty crazy. I want to take a couple measurements, other things real quick. And I need to set that better. I need to go pee first. That's insane. I'm not pulling any current. None. On this, anyway, let's put a digital multimeter on there, see me an actual current I'm drawing. Let's put a digital multimeter on here instead of this analog meter. Okay. Nobody's watching this. This is awesome. I'm seeing some results I've never got to see before. Things are starting to work. I am. Good. At least somebody's seeing it. Okay. 300 milliamp. And this sucker would blow up. So let's not go over that. So let's start really low. You know what? I don't have any. Thought I had some banana plugs. No, I'll just get another one. Okay. This is DC milliamps, okay? I can only get to 300. So this is 1.22 milliamp. 5 milliamps. 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 I'm at 400 volts. 400 volts. Look at that. Now granted, I am putting 30 volts into this switch, but I'm getting out 630 with the water capacitor connected at 31 milliamps DC. I gotta go pee. I'm gonna let this sit while it's charging. Be right back. Okay, I'm back. Stan says 2000 volts. I'm not at 2000 volts, and I don't have a high voltage probe. So, let's turn this voltage way down. Okay, we're at 150 volts. Let's see. 150 volts output, peak to peak. 3.7 milliamps, 6.6 volts. Now I'm going to take measurements of my system and see what we get, and compare that to what GPS was getting, and compare that to what WebMug was getting on that cheat sheet that they made up. Not a cheat sheet, but it's just a picture they posted. I'll pull that picture up so we can compare. I gotta find it. Where did I put it? Let me just go get another one. I don't know what I did with it. That's pretty impressive. I haven't been able to get this far yet. So that's pretty good. Where is this thing at? Okay, where you at? Where you at? Where you at? I downloaded it earlier, now I can't find it. I mean, I know where it's at. I can't find it on my computer. Okay. We're getting there. Patience. There it is. Okay. Save image as. I already did this. And there it is. What? It's right in front of me. I know where I put it. It's in the other folder. Imagine that. Alright, let's see if I can add this to the screenshot. Add a photo. Diagram. Okay. I got so much stuff. This is pretty impressive. I don't know about you guys, but I'm pretty impressed that it's working this well thus far. I should be able to do this with lower input voltage, but I think that's a matter of tuning. I just started. There. Alright. You guys see that? Alright. So I'm just going to leave this right here, and I'm going to go each one of these, and I'm going to measure them. We're going to see what the signal looks like. So from A to B, so which is across the secondary. I'm getting this. I'm going to move some of this around, let's see. And then, let's see if I can move this up too. Okay, so that's what I'm getting. Okay, on the other side of the diode, that's what I'm getting, which there's a little undercut. Doesn't really look much different, does it? Let's compare those again. Okay, one side of the diode. Other side of the diode. Again, I got my voltages really low. Alright, so that was from C to A. So D to A is going to be I might have those backwards. I might have to change that. That's the signal that we just had. That's this one. And then if I measure E to A, which is the other side of the choke, just this one, that's what I get. That looks about the same. Let's measure across the cell. Let's see if I truly get that weird step charging visual. Might have to get another lead here. You know, I've never measured it quite like this. Maybe that's part of the reason I'm getting a different result. So that's across the cell. Across the cell, I'm not getting like anything. What does that tell me? It don't tell me much. Let's crank it up. Crank up the voltage and see what I get. Look at that. I still ain't getting nothing really across the cell though. Why is that? That must be the voltages inside the coil that I'm measuring. But let me watch the meter carefully and change something here. Let's see, I better turn that down. Let's try that. I'm still at 10 times on my probe. I am curious. Let's play with the... I'm at only 11% duty cycle. So... we're at 1% duty cycle. Let's go up until I get to about 200 milliamps. See if our signal changes on our cell. Look, it's rising. It's going up in a positive potential. So that's a good thing. We're only at 50 milliamps. We're at, there's 50% duty cycle, so you can see it rising. Oh, there, look at that. It rises after I quit. That's just weird. Granted, it's only a volt. But I'm only at 13 volts. Let's just keep going. Oh, that's peak to peak. Now let me measure ground to peak. Let's see. So I'm getting 11 volts out. Let's leave that up and keep going. Okay, we just went over 100 milliamp. We're at 85%. I think I need just a lot more tuning. Let's remove the measuring. It's humming pretty good. That's only 13 volt. Let's bring the voltage up just a tiny bit. So I still have my probes set right. This one's on ×10, yep. And that's on ×10. Check out that really peaked after it quits. What happens if I... What happens if I change how many pulses? Look at that peak. Let me see what I'm measuring. That's 15 volts. It's doing some weird stuff there. Let me see if I can measure. I'm at, oh, I went down. I'm only at 45. So let's see here. I should be able to measure one more. I don't have 4 up there. So I want to go And we're at 290 milliamp. Okay. It's interesting. Here, let's take this meter back offline so I can pump more through it. So I got the current set. It's negative. Clip this back on. Remember, this is measuring across the cell. That's 80 milliamps. Change the frequency on it, 788. Change it by 10. I want to see what we did, what happened. That was higher, let's go lower. Duty cycle down. Amp and a half's my max. Alright, let's put this back at 50% duty. And we're just going up. It's changing how many pulses are happening. Alright, well, interesting nonetheless. So, Let's try... Well, it shouldn't matter. See, I'm going to put this at 2 volts. And I'm going to measure back where I was originally. So that's basically across the secondary and across the second inductor. That's what it looks like. And my voltage across my cell isn't very much. I've definitely got some serious voltage going on here. That's at 2 volts. So now let's play with this. Changing the duty cycle. There I'm at 10% duty cycle. 1% duty cycle. Change the frequency a little bit. There, I'm getting out of it. Let's do 100s. Let's see if there's any other sweet spots. There was one. You know what I'd like to do? Let's try something else. Let's hook up my signal generator to the input. And I can't really do pulse train very well on here. Let's do a frequency sweep and just see what kind of things come out about it. So let's do this. Find the right parts. There we go. Okay. So let's do this. Take this one. Turn off this. Take a quick measurement. I think it's 3.3 volts. Guess I need to turn that back on. .8. So we'll say 3.3 volts. So we're going to set this 3 volts peak to peak. This is 0. Where are we at? 7. No, we were at 6, 8, 8. So 6, 8, 8, 0 hertz. Put this back how we had it. We're at 10% duty cycle. So we're going to have to do pulse. 10% duty cycle. Okay, so if I do this right, we should get this exact same signal, or really close to it. Except I don't have gating on, so I'm going to have to turn this off. It's going to look like that. This needs to be on times 10 though. 30 volts. 2 volt in. Okay, so if I do this right, I should get the exact same signal. different cable. There it is. Alright, so we got our signal. There it is, 7888. Now I'm using my frequency generator. Okay, now I can do a frequency sweep. But for now, wow, I'm getting even more voltage there. That's 11.8. Is that double? What's double? Let's see, it's 7. Where's my calculator? Let's use this one. 7,800 times 2 is 1560. So around 1560 we should have had something to do if that was true. That's even better. Still not good every time I switch. It goes crazy. Alright, well let's go back to 2 volts. Okay, there's 2 volts. And let's get back to 7880. Let's do a frequency sweep. I'm gonna do square wave though. Let's do 50% duty cycle. Alright, let's do a sweep from start at 100 hertz and stop at 1000 kilohertz, 100 kilohertz. We're going to do time. We're going to go with 30 seconds. Whoa, you see that peak? Watch it again. It's going to start over here in a second. And then we're way outside our range. Let's go with 50 kilohertz. That was 22 kilohertz. That peak. That was about 32. It's like dead after that. It's dead after like 15 kilohertz. So let's just put 10 kilohertz, or 20. Or let's put 15. We're at like 23 at a high peak. Oh, I'm at 23 kilohertz still. Only going to 32. Something happened. Let's put back in 40. There's 23. But it was a smaller peak. And it just kind of flatlines. So let's change this to, said 23, let's change it to 25. Change the time down to like 10 seconds. Yeah, right around 23. So I'm starting at 17 kilohertz. Let's start at 100 hertz. It's pretty fast, but we're at like 23. Let's start at 22 kilohertz. Stop it. 24. Again, this is 50% duty cycle. Let's go back to square wave with no sweep. And let's put in 23 kilohertz and play with it here. 23,680. Let's just turn up the voltage a little bit. $200 milliamps. 7.5 volts. Guess I'm gonna have to. I really need a spectrum analyzer. Okay. So I don't really need that anymore. Oh, what time is it? Oh man, I'm getting tired. I should go get some more coffee. I'm gonna go get some more coffee. I'll be right back. Ah, coffee. Coffee break. All right. Let's do another sweep. We're gonna go from 100 hertz. Actually, let's go from 10 hertz. We're gonna stop at 40 kilohertz. And we're gonna do that. In 30 seconds. No, we gotta do it slower than that. We're gonna do that. In 60 seconds. So I could turn up the voltage if we really want to see a spike. We're going to really watch it. I should just write down all the frequencies at which it has a peak. And go investigate them. I don't have a spectrum analyzer. Need to get one. There was that 7.8 little bitty peak. And there's that 23. Look at that big old peak. 23. Mm, 32, 31, 32. Let's watch it again from the beginning. There's that 7.8 with the doubling. Oh, a single. That's why I went with the lower one, because we didn't have the doubling. At 23 we still don't have the doubling. That's why I did that. Something weird just happened there. Let's do this again. Let's go from 20 kilohertz to 30 kilohertz. Like the phase angle change. That was interesting. Look at it. It moves, it advances. Check that out, it like changes the phase. Now watch it again when it does it. Oh, it flips, it inverts. That's what it did. Hope girl, baby, all the way. Here, watch Watch it again. Starting over now. Look at it, it shifts forward. It's kind of different. But we don't get what I want, which is doubling. I think that's what I'm looking for, a little bit more than anything. Just playing around here with some stuff. It's freaking hot. One thing I do want to try though is I'm going to switch around my secondary coil and just see if I get the exact same effect. So 23 and 78, 68, or no, 78. Let's just see what happens when I switch these around. They're on different cores, so it shouldn't matter. But maybe it does. I have resonance. Woo! Let me make a big stink. I do find it really funny though, that whole situation. Situation's pretty funny. Okay, so we flipped around the secondary just to make sure. Nothing fishy's going on with that one being switched. But again, because it's on separate cores, it shouldn't matter. So here we go. Wow. I don't have this hooked up. That'd be why I did that. I'm like, something changed. That would be why. It's lower voltage. I have to watch it again. Let's go to stop at 25 kilohertz. And then let's change our time down to 30 seconds. Oh man, still looks about the same. I really don't think it matters because it's on separate cores. But that's not frequency doubling. So, turn off our sweep and put it back at see, there's our frequency doubling. Well, all that is the field collapsing and pulsing and collapsing and pulsing at the right frequencies, which isn't that difficult, but let's see. Let's try to tune it slightly better. There you go. That's it. Again, we're at 50% duty cycle. About 74 volts at 2 volts input, 1.9 volts input. So let's crank the voltage up again and see what we get. That's 200 milliamps. Now, let's change the duty cycle. Goes down. Let's put this back at 2 volts. See, I really think you need to get it tuned at this very, very, very low frequency. Or, not frequency, but voltage. You don't need that much voltage. 2 volts should be enough to make it work. My feet hurt. I should really get that big bench stool over here, but let's do pulse. Kind of negative. Oh, fuck. Whoa, what happened to my output? Oh. Below my minimum. See, around 50% I get that really nice. .76 volt. Check that out. When I get to a certain pulse, it just kind of kills it. See, look, there's 3. So what that tells me is that I've got 4 times the frequency right there. See, watch. Wait, how's that measuring it? It's not measuring it right. Then my frequency down here is not measuring correctly. Let's try this. Now that I've got such a low pulse width, what happens if I bring my frequency down? Can I get it to be doubling again at a lower resonance? I wonder if it even matters. Actually, I think I have to go up in frequency, don't I? Not down. There, we just went past our other resonant point right there. So I change. Oh wait, that's 1, 2. Yeah, that's doubling. And it shows it. I'm at 11.44 and I'm at 2.88. And again, that's it. That's because I changed the duty cycle to 10%. And I'm getting the same amount of voltage. go even lower. That's crazy. About 3% duty cycle. Duty cycle affects frequency, which makes sense. Just put it back at 10. Let's crank this frequency up now that our voltage. See if it really grows with it or not. See, the amperage is still showing like nothing. Now it's at 100 milliamps. I'm sorry, 10 milliamps. What happens if I disconnect the cell? Well, check that out. That's just from reaching into the system. It's getting close to the inductors. This is grabbing a cell. Just look at that. Look how much affects that. Gee whiz, man. What does happen if I disconnect the cell? What happens if I reverse? The cell input. Now I'm hooked up to the opposite potential. I'm off the scale, man. Get times 100 probe. Alright, now remember, I changed the duty. There you go, now I'm changing it back. There's a kilovolt. I can't even measure this. How am I supposed to measure this? I do have this 800 meg ohm resistor, but what happens if we try a... Let's see. Let's just go for 100 meg. If we attach a 100 meg resistor from here to here. 100 meg should drop our voltage. So this is, it says, so this is another times 10, or times yeah, there you go. So I put the probe at times 10, and in theory that voltage should be right. So let's see. That's it, that's my maximum voltage. Oh man. changing the duty cycle again. Let's bring it up to 50%. Check that out, it went whack. Not 3,500 milliamps. Back at 10%. I'm going to change the milliamps back down to 2 again. 25 milliamp, 250 milliamps, sorry. Well, quite interesting nonetheless. I'm at 2.8 kilovolts in theory right there. So what happens if I switch it again? Wow, well, it went way up. Thing is I don't know if you guys can hear that high peeling switch squeal, but I can hear it quite nicely. Okay, I don't know what to think of it really. Just for fun, let's just untune these suckers. Let's really open them up, so we have to have a low frequency. Okay. So we've opened them both up. They're totally random. Let's go back to 50% duty cycle. Do another sweep. 10 hertz to 25 kilohertz. We're at 10 amps, or 10 volts, sorry. That's current limiting. Oh, did you see that? Let's turn this back down to 2 volts. That's what we've been playing with. And I'm going to change this to stop at 50 kilohertz and start at 20 kilohertz, because it actually had a little nice peak there. Right there. What's that? It's only like 300 volts. Oh, but we're only at 2. We're only at 2 volts. Let's watch it some more. Yeah, it's way out. Let's watch it again. Too low amplitude. There. So that's 26 to 27 kilohertz. Alright, so let's just go there and see what happens. Okay, that's 200 volts. Now let's leave it right there. 26.8. Now let's turn up the voltage. So I'm actually lower with more, but let's change the duty cycle. Then I can bring the voltage up more. I got my power supply set to low current. See, that's not doubling though. That's another thing. Let's put the duty cycle, I changed the duty cycle. Let's put the duty cycle at 10%. And let's change our frequency. 26.86. Here's my doubling. More than doubling. I'm making big changes. I need to make smaller changes. Hold on. There's my doubling. Can't get the same voltage out of it though. Then again, I'm using a lot less power. Alrighty then. Well, what happens if we crank these all down? Tight as they'll go. That brings the inductance like way off the charts when you do that. Close that one. Oh yeah. Hear it squealing? Okay. Turn the voltage back down to 2 volts. And that's high pitch. Okay. Dang, we're 80 volt. Man, that's high pitch. So let's do a sweep from 10 hertz. Whoa. Let's watch again. Oh man, we're way too high. Lower, we hired the inductance, which lowered the frequency. So let's lower it to like, let's lower it to 20 kilohertz stopping point. So anything past 10 kilohertz and it's no longer frequency doubling. There's a nice little peak. Big peak, about 18 kilohertz. Let's just play with that real quick. Okay, don't forget that's not a perfectly accurate voltage because I'm using a resistor that's not very good. Definitely doesn't act the same with the voltage. Figured out about right. Strange. The higher the voltage does not do the same thing as it did. Let's go find the other resonant point with the voltage doubling, or the frequency doubling. Right in here. See if this does the same thing. Okay, again we're at 2 volts. Yep, does the same thing. We're at 10% duty too. 20% duty. There's 50% duty. Okay, so it worked much better when I calculated stuff out. That's good to know. So let's set these at the 500 hertz point. It'll be about time for me to go, actually. My feet hurt. I think I want to try tuning these again. I'm just totally guessing at this moment with what I'm playing with at this second, as I just messed up my measurements completely. But actually, let's go here. Okay, let's try this. it's calling. Yeah, well. David, you're on your own for a minute. Alright, let's turn this off. Let's disconnect everything. And take some measurements. Primary. Needs to be at about 200. Millihenry, and that's running at 1536, but that's the high one. So we're going to tune these with the same frequency again. Okay, so let's see what the other one's at. I'm going to switch this diode back around the way I had it the first time. I have to unsolder it anyway. Okay, and this one's supposed to be it. Man, that's hard to get with the lower values. The higher values are easier. I mean, the lower values are easier. Whoa. Alright, so again, let's tune for this, because that is so far off. I'm going to go with 90 Henrys, which is 900 millihenries. Henry's at 90. Maybe I can't even get to it. Here we go. This doesn't look like a good idea. I don't think this one's going to work well. I need to pick something that's tighter in my tolerances. Oh, we're not that far off. So 900 millihenry. That's what I'm tuning for. We're running at 626 hertz. Let's just see how well that adds up to my other two when I try it. I gotta pee. Be right back. Someone else is in the bathroom. Here, let me take the take that off so you can see what I'm doing. Okay, so we're gonna leave that one there. And we're gonna do this one. Okay, this one needs to be at. See, this is L1. L1 Seems to be at about 1 Henry. And if it is, it should be close to 626 hertz. Should have tuned these first, because these are a little off. I can't get these exact, so I'm going to have to rewrap them so that I can get them equal with my measurements. Okay, that's at 688 hertz. So just for fun, what happens if I tune it at 626 hertz? That's going to drop it quite a bit. Drops it to 1.21. Let's just try that. See what the other ones read and see if we're close. This one's at 0.9 at 708 hertz. So that one's too high too. So what we'll do is we'll match these until they both are at the same frequency. Then we'll retune the other one. 676 hertz. Now we're at 600. We went down. I don't think that's going to be an option. So we'll cancel that idea for now. We'll just try to tune them close as we can to the right number. This is supposed to be around 8. That's 8.4. Well, let's see, that one's supposed to be around 1. I had the wrong one. Try it again. See, I'm gonna have to rewrap these. That's around 8.4. It's pretty close. We'll leave it right there. See, that's 8.4. And this was right at 1. And the frequency is supposed to be around 10 kilohertz with this. Now the other one was a little off too, but see what happens. Okay, this one goes here. This one goes here. Let's see, I gotta look at my diagram again. I don't want to get it wrong. Start goes to the secondary. So I switch these. Finish goes to this. Those two. Okay. Hook this coil back up. And we're off to the races. Just dial in 10 kilohertz. And go from there. Now, last time it was, I think, lower. There it is, your frequency doubling. So we're pretty close. But it's still nowhere near. Actually, I guess that's not bad. Let's just ram the voltage up and see what we can get out of it. Yeah, not the same. And the potty's open and I have to go pee really, really bad. So you're gonna have to wait. Ah, much better. Alright, so I was better off at my tuning around 7,500. And I can try tuning at 5,000. Which I think would be a good idea. Okay. Let's get a straight reading again. No, you're not on the chat. Get on the chat. Yes, it is. Type any name and hit enter. I'm just about to quit though. I'm done for the day. I should be leaving in 10 minutes, but I'm interested in what I'm doing. Tell you what, I'm gonna plug this back into here. And I'm at 29. 29.2. Oh. You still can't get the chat to work? You see me, eh? One. Okay, then we'll do 400. And now we can do more. So we should probably put like 5,000 and add a bunch. There we go. Let's change this at 50. All downhill. There we go, that's an uphill. Won't let you send a message. Are you logged in? Oh, it did quit. Dang. You might have to refresh your page. Just refresh it and log back in. Now it's working. Refresh your page, log back in. Alright, let's just stick with 50. What? It's broken? Mine works just fine. Anyone else in the chat room having problems? Yeah. Yours is broke then, David. You're just on your own. What are you using? Firefox? Something else? And I like this system tuned back at what I had it. It was much, much, much better. Ah, boy. You're on your own. I got nothing for you. Okay. So, I'm just gonna detune this thing for fun. Just to see. Maybe I can try to tune it even better, but I doubt it. I do that better with the frequency. Let's see, my other ones were closer together. So let's just kill it like that and bring it back up. Triple. Oh yeah. Man, I need to put the trigger on the other thing. But I want to see the waveform. Where's this cool function I could use that I haven't? Too. Alright. I've just completely detuned this sucker. I should probably go home now. I gotta unhook it and redo it. Definitely nowhere near where I was earlier. I was really hitting it good earlier. Okay. I'm gonna do just that. I'm gonna go home. Alright. Okay, it's 4 o'clock anyway. I'm supposed to be leaving now. So I should. And I gotta pack up all my crap and put my things away. Well, my beginning tests were looking a lot better than these right now, weren't they? That's all good. Check that out. It's still pretty good for what I'm doing, for what I'm using, voltage wise. Oh, yeah, my mic is kind of whack. I can change the frequency like that, but I don't know if it helps. Alright, I'm shutting this show down. I gotta go. Ooh. Okay. I'm out. I'm gonna upload these real quick, I think. Out.